Hello everybody, today is Wednesday. We're going to learn a little bit about nets. First, pyramid nets. Now the most common thing about pyramid nets is that there's one base that identifies the pyramid. For example, this right here, this is a square, and there's 4 triangles, 4 flaps that fold up to one apex. So this here is a square pyramid. This one right here, well, that's 6 sides. That the prefix is hexa. So this is a hexagonal pyramid. This one right here, it's a pentagon. I know because 1, 2, 3, 4, and 5. So this right here is a pentagonal pyramid. And now the question yesterday was, how many edges does a pentagonal pyramid have? Well, we can use this website right here that actually is pretty helpful. And here we go. It gives it to us here. The number of edges is 10, and we can highlight the number of edges and count them as the shape rotates. It also has a nice surface net there for us to see. But let's go back, and this website, by the way, is on the front page of your Do Now worksheet. But now if we go back, slideshow from current slide. Now let's count the number of edges. There's 5 here. 1, 2, 3, 4, and 5. That makes sense. It's a pentagon. And there's going to be 5 from each vertex. That's 1, 2, 3, so that's 6, 7, 8, 9, and 10. So a total of 10 edges. The number of vertices, well, there's 1, 2, 3, 4, 5, and 6. And then the number of faces, there's the one base, the pentagon base, and then 5 lateral faces around. So that's a total of 6 faces. Okay, now let's go to prisms. So prism nets here. Now the most common type of prism nets that I think is most easily seen is things like this, where there's rectangles in between the 2 equal bases. So prism net always have exactly 2 equal bases that name the figure. So for example, I'm going to move it just a little bit over here. This right here is a triangular prism. This one right here could be a rectangular pyramid. Prism. Or it looks like this is a square or a square. A square is technically a rectangular prism. Here this would be a pentagonal prism, hexagonal prism, 7, heptagonal prism, octagonal prism, enneagonal prism, and 10 is a decagonal prism. Now this is, if you see these surface nets, these can wrap up and the 2 bases can fold together. I have my surface nets back here. For example, so like this is the hexagonal prism that can wrap around and eventually make the hexagonal prism. So the rectangles in the middle were just shifted over, but it'll still wrap around and make that hexagonal prism. Now here, this one, these also wrap around, although there's not quite as many, and they still make that prism. And I have one more, the rectangular one wraps around and makes the rectangular prism. So it actually doesn't matter where these rectangles are. Or you could see something like this. Now I don't have any surface net like this for this, but this still would make, well, let's count how many sides. 1, 2, 3, 4, 5, 6, 7, 8. this still would make an octagonal prism. All of these could fold up, and then the second base could fold down. But I know that this one here is going to be a prism because I see many rectangles on the touching every single side of the shape. And I also see two equal bases. Two equal bases. Now, is there anything else? Oh yes, that's right. Next part of this is the answers from yesterday's work. Also your homework. Let's see if I can get a good view of this. Okay, I think this will be... I will print all of this out for you, and you can follow along as well. I'll print it out in your Do Now worksheets, but I do just want to go over the answers. So for problem 1G, the answer was 106 meters squared. For problem 2G, the answer was 352 inches squared. Hello. The answer for problem 3G was the lateral surface area. Make sure you don't include the top and the bottom. Those are bases. So the final answer is 140 meters squared. The 4G, hello, was don't include the bases, just include the lateral area. So the stuff that's around it, just the front and the back and the two sides, was 288 meters squared. It's late and I'm tired. Over here, problem 1S was 168 meters squared. And problem 2S was 216 meters squared. Remember, do not include the bases for lateral surface area. But I want to zoom in a little bit on one problem here. If you could notice how I did this problem. Okay, now I tried to do it as organized as possible. Notice that I have underlined front and back, and I do the calculation. Two sides, and I do the calculation. And finally, top and bottom, also known as bases. I should have did parentheses bases. I did that for the problems. And then I add them all up and I get the total area. It's very, very important when doing these problems to stay organized. Stay organized. If your work is all over the place, you're going to have limited success with these problems. All right. Thanks.